Alright, this is the second part of 11.1, and in this part we want to be able to do Lewis structures for covalent compounds, and we want to talk about single, double, triple bonds, and talk about pairs of atoms that will form covalent bonds. So we've talked about this, we've done this a little bit before, but Lewis dots are much easier to use to describe a molecule. So, if we had something like hydrogen, we could say hydrogen has one pair of shared electrons between those two. And these dots here are used to indicate a shared pair of electrons when they're kind of written between like that. And sometimes we just put a dash instead, and a dash indicates that same thing. But we only use valence electrons when we do this. We don't worry about the other ones, and that's what kind of makes it a little bit easier. So if we were going to do, let's say, fluorine. So let's think about what fluorine looks like. Each fluorine has 7 valence electrons. And so we're looking at F2. And so if we have another F here, you can see that in order for these guys to create an octet, to get that 8, if they share these, when they share, they both get to count them. So this pair of electrons in between here, let's make it look like dots here. This pair counts for both. So if we're counting for this fluorine here, we can say, hey, 1, 2, 3, 4, 5, 6, 7, 8. And if we're counting for this fluorine, we can do the same thing. 1, 2, 3, 4, 5, 6, 7, 8. So when you share electrons, you get to count both of them. So when you see 2 dots in between the letters, or like I said, you might just see a dash, and the others would be dots, but those the ones shared pair would be a dash. Oxygen's going to be a little different in that it's got 6. So when it's trying to make its 8, if we share those 2, now they'd be up to 7. So we got to share another pair and get us up to 8. So those 4 electrons, or those 2 electron pairs, are going to be shared. And we would rewrite that. We don't want to leave it that sloppy. So we would rewrite it looking like that, or rewrite it like that. And covalent bonds can also form triple bonds. If we have nitrogen has 5 electrons in its outer level. Oops, let's kind of fix that here. And so, we can share there, and there. We make a triple bond, and all of those count. So if we count these 2, 4, 6, 7, 8 for that one. 2, 4, 6, 7, 8 for that. So of course, once again, we don't want to leave it like that. We want to write it a little bit neater. So it would look something like that. That's our Lewis dot structure, or you could have the 6 pairs of electrons in between there. And all right, let's do some more. And one of the things that you have to do is kind of think about structure. Because up to this point, we had diatomic ones. They were just the same thing. But now we got to think about, well, how are these going to be put together? Now, typically, when you're looking at molecular compounds, they tend to be quite often symmetrical. They tend to usually have like one element that goes in the middle, and the other ones go around it. So if you look at phosphorus, okay, and then you've got chlorines, and they go around the outside. The other thing to think about is things that are in group 7, like all the halogens, fluorine, chlorine, bromine, iodine, they can only make one bond. They only want one pair, so they're not going to be in the middle, because middle ones tend to form 2 or 3 or sometimes 4 bonds. And so in this case, phosphorus is going to go in the middle and put our dots around phosphorus. Chlorine is going on the edges, and each one of the chlorines gets 7. And so it's going to look like that. And we're going to share those there, there, and there. So this is my structure, my Lewis structure for the PCl3 molecule. Okay, let's take a look at this one. Once again, we want to figure out, well, how's it going to look? How's the structure going to be? And just like in the group 7, hydrogen can only form one bond. Hydrogen has one electron. The max in the first level is 2, so it only needs one more. So hydrogen is only going to form one. So our oxygen is going to go in the middle. So we're going to put oxygen in the middle. And because I know a little bit about the structure of it, I'm going to make it look like this, because that's kind of how it really looks. It looks like a kind of a bent L-shaped kind of a molecule. And so here's our shared pair here. Hydrogen is full with 2. Here's our shared pair there. And oxygen gets to count these as 2, 4, and then 5, 6, 7, 8. So it's got its 8 electrons that it's always trying to get. So there's my Lewis structure for water. Carbon dioxide, let's take a look at that one. Once again, like I said, a lot of times these things tend to be symmetrical. So this is an unlikely, something like that is probably not as common as putting carbon in the middle and oxygen's on the outside. And carbon happens to be one of those elements that loves to be in the middle and loves to form a lot of bonds, because remember we talked about how carbon has 4 valence electrons, so it likes to do the covalent sharing. It doesn't do a lot of ionic sharing, because trying to gain or lose 4 electrons can be kind of difficult. So let's kind of take a look at how this is going to work. So I always draw my valence electrons in, kind of thinking of my structure before I start, and then I've got to figure out, well, okay, where are these that I'm going to pair up? Oxygen right now is missing 2, so that means I need to make 2 bonds with oxygen. So I'm going to bond there, I'm going to bond there, and then I'm going to bond here and here. So that's kind of my 4 bonds that carbon can make. Carbon usually makes 4, oxygen usually makes 2. And once again, rewrite this. Don't leave it like this. Okay. So oxygen is going to look like that. It's got 4 electrons that are not in bonds on each side. And oxygen and carbon has all 4 of its electrons bonded now. So there's 4 electrons being shared here, 4 electrons being shared there. So for carbon, 2, 4, 6, 8, it's happy. For oxygen, 2, 4, 5, 6, 7, 8. For this oxygen, 2, 4, 5, 6, 7, 8. You always need to make sure that we get to 8. Now, there are exceptions to that, but most of the ones that we'll do get to 8 electrons, and that's what we're always trying to get to first. All right, NH3. So think about, once again, what's my structure going to be? Remember that hydrogen ones always have to be on the outside. Therefore, the nitrogen is going to go in the middle. And we've got hydrogen, and we'll just kind of put them around the nitrogen. And if we give nitrogen its 5 and hydrogen its 1, and there's our bond, there's our bond, there's our bond, and everybody's happy. So you're always trying to get to 8, except for a few things like hydrogen, which is only trying to get to 2. Okay, now it's your turn, and honestly, this is the best part, is if you try to figure these out. And on a couple of them, you might struggle just a little bit. So what I want you to do is try to do all of these. In a little bit, I'm going to give you, I'll write down what the structure looks like. I'll kind of put it in the order, and then maybe if you didn't get them figured out, you can go back and do it again, and then I'll do them for you eventually. Alright, so if you didn't get the skeleton written for them, then this is what it looks like. For CS2, carbon's in the middle, sulfur is on the outside, PF3, phosphorus in the middle, fluorine's around the outside, C2H2, it's kind of a chain like this. You got hydrogens on the outside, carbons on the inside. Same thing with H2O2. The oxygens have to go on the inside. Remember, on these, you can't put hydrogens ever in the middle. They can only make one bond, so in the middle, you have to make at least 2. And and the last one, the carbon goes in the middle, hydrogens go on the outside. So if you didn't get it figured out, stop it again and finish those. Alright, so let's now draw them, and you can see that each sulfur needs to form two. So there's one, there's two, one, two, and carbon always forms four. So you end up with this kind of a structure. Should look something like that. 4 unshared electrons around each sulfur, 2 bonds between sulfur and carbon. Alright, for PF3, we're going to form 3 bonds with phosphorus. So 1 to each fluorine. It's going to look something like that. And you get your PF3. Should look like that. Okay? Okay, if we try to do this one, we know that each hydrogen can only do one, so let's make those. And so the hydrogens are happy, but each carbon needs to get 4 extra, so basically that's forming 4 bonds. It's only got 1, so there's going to be a pair shared there, a pair there, a pair there. So you're going to get something like this. So you could draw it all out with the dots, or probably easier, you could draw it out with the lines to represent. Each line, remember, represents a pair of dots. With hydrogen peroxide, it's going to look like this. Those are all going to form single bonds there, pair for each of them. They'll all be happy. And on this last one, once again, carbon wants to form 4. Each hydrogen can only form 1. So we're going to get that. The overall is just going to be a CH4. There's going to be all bonds, no unshared pairs. Would look like that. And that's the end. And I guess I don't have a joke in here on this one, so...